Chapter 5, Section 2, the periodic table. Key ideas. Why do elements within a group of the periodic table have similar chemical properties? And what happens to an atom that gains or loses electrons? What are the three main categories of elements? So, the electrons play a large role in how elements or atoms will bond and how they will behave. And so periodic trends in the periodic table are the result of electron arrangement. The valence electron, or the outermost electrons in an atom, are what accounts for elements having similar properties. And so an element's location on the periodic table is related to electron arrangement. For example, lithium and sodium both have only one valence electron. They are both in group 1, or the first column on the periodic table. If an atom gains or loses electrons, it no longer has an equal number of electrons and protons because the charges do not cancel completely. The atom has a net charge, or a net electric charge. So what that is talking about is lithium. Its atomic number is 3. So that means it has 3 protons and 3 electrons. Protons are positive and electrons are negative. So if it has 3 and 3, then its charge is going to equal out to be 0. But if it loses an electron and now has 2, then we now have 3 pluses and 2 minuses. And so now we have a net charge of +1. Same as if it were to gain an electron. So it has 3 originally. If it were to gain an electron, now it's got 4 minuses, and it still has 3 protons, 3 positives. So now its net charge is going to be -1. And so if an atom gains or loses electrons, it will no longer have an equal number of protons and electrons, no longer have a 0 charge. Group 1 elements form positive ions. And so elements in group 1, like we just said, have 1 valence electron. And so it is easier for that atom to give away 1 electron than to gain 7. So the single valence electron is easily removed. Now, when we're talking about ions, atoms want to be stable. And so in order for an atom to be stable, it needs to have a full valence shell. So thinking back to the Bohr models that we've done, you can have up to 2 electrons in the first ring and 8 electrons in all the other rings. So if you have an atom that has 2 electrons in the first ring, and that's its only ring, then it has a full valence shell. If you have an atom that has electrons in any other ring, then it has to have 8 valence electrons to be stable. So group 17 elements form negative ions. And so elements in group 17 have 7 valence electrons. And it is easier for them to take 1 electron than to give away 7. And so think about it in terms of money. If you were trying to get like a video game that you really want and you have $40, would it be easier for you to ask a friend for $10 or to give the 40 to the friend and let them go buy the game? Or vice versa. If you've got a game that you really want and you and your friend are going to go in together and buy it, would it be easier if you only have $10 to ask your friend, hey, give me 40 so I can go buy the game? Or, hey, I'm going to give you 10 and you pay the 40. So with group 1 elements, they form positive ions because it's easier for them to give 1 away. Group 17 elements, it's easier for them to take 1 electron to become stable. So all elements are either classified as metals, nonmetals, or semiconductors. We also call that metalloids, which means that they're kind of like in between metals and nonmetals. Elements in each category have similar properties. And so metals are all going to be things that are shiny. They tend to conduct heat and electricity well. Nonmetals are elements that are poor conductors, and generally they're going to be more dull in appearance. Metalloids are elements that conduct electric current better than nonmetals, but not as good as metals. Basically, a metalloid semiconductor can behave like nonmetals in certain situations or like metals in other situations. And so here are some examples. Again, metals are good conductors of electricity. They are good conductors of heat. They are ductile. Ductile means that you can stretch them out into a thin wire without them breaking. Metals are malleable, which means they can be hammered or hit and easily shaped without busting apart or breaking. Most metals are shiny, so not all metals are shiny. Some examples are copper and lead. Nonmetals are poor conductors of heat and electricity. They are not malleable, so when you hit them with a hammer or something, they're probably going to crack apart. They are not ductile. You cannot pull a nonmetal out into a thin wire. And most nonmetals are not shiny, so you have carbon and sulfur. Semiconductors share properties with metals and nonmetals. They can conduct electricity under certain conditions. They are the main components of chips in computers and in other electronic devices. And so some examples are tellurium and silicon.